So when we have these quadratic equations, if we want to use a quadratic formula, what we need to do first of all is we need to make sure that we make it equal to 0. So we do 2c squared minus 25c plus 77 equals 0. And really all we need to do is identify a, b, and c. So a equals 2, b equals negative 25, c equals 77. Okay, so we're going to end up plugging into the formula. So c is equal to negative of negative 25, so positive 25 plus minus 25, negative 25 squared, 625 minus 4 times a times c. Okay, and then we end up with over 2 times a is equal to 2, and then we just work this out. So we end up with 25 plus minus square root of 625. Okay, so it's going to be 8 times 77, so 8 times 70 is 560, and 8 times 7 is 56, so minus 560, so 616, I think. So 56, 560, and then plus 56, yeah, so 616 all over 4. And then we end up with 25 plus minus the square root of 9 over 4. So this simplifies to 25 plus 3 divided by 4, which is 20 divided by 4 is 7. 25 minus 3, which is 22, divided by 4, which is 22 over 4, which simplifies to 11 over 2. Okay, so those are two solutions to that quadratic equation. Again, here we want to get rid of the brackets. 4x squared plus 2x. Make it equal to 0, so do minus 3 on both sides. Identify our a, b, c. So a is equal to 4, b is equal to 2, c is equal to negative 3. And then plug it into the formula. So we end up with negative 2 plus minus square root of 2 squared minus 4 times a times c, which is negative 3. Okay, and divide this by 2a, so we're going to end up with 2 times 4, which is 8. Work this all out. So we end up with 4 plus 48, it looks like. So we're going to end up with square root 52 divided by 8. Okay, we really should simplify this. Now that's not a perfect square, so we can just leave it like in the radical form. We don't really want the decimals because we really should be keeping exact values when possible. But we should simplify this. And we should factor out the perfect square of 4. So we end up with 2 root 13. And then we can simplify that fraction by a factor of 2. So we end up with negative 1 plus minus square root of 13 all over 4. Okay, and this is our final solution. Okay, so these ones here, what we want to do first is put it into a quadratic form. So we need to get rid of the denominator. We should state our restrictions. So x, we can't divide by 0, so x can't be negative 1 or 1. What we want to do then is we want to get rid of the denominator by multiplying by the lowest common denominator. Okay, we'll use those factors there. So we end up with 3x squared is equal to x plus 1's cancel out, so we end up with x times x minus 1 plus x minus 1's cancel here, so we end up with 1 times x plus 1. Okay, multiply this out. These cancel out, so we end up with 2x squared minus 1 equals 0. Now we could solve this algebraically because we already have a perfect square here that we can undo, but we could still use a quadratic formula. Again, we just need to identify the a. In this case, the b is missing, so we get 0. So this means that when we put it to the quadratic formula, our center will be at 0. Okay, so we do have symmetrical roots. And c value is going to be -1. Okay, plugging this in, we end up with -0 plus minus square root of 0 minus 4 times a times c all over 2 times a. This works out to be the square root of 8 plus minus all over 4. This simplifies to root 2 over 2. Okay, so plus minus square root 2 divided by 2. And so we would have ended up with the same thing here if we just solve for x. We would end up with negative or 1/2 square root of 1/2, which is the same as square root 2 over 2.